repetition of brain structure, mutual understanding and mutual aid, self-learning and rethinking of biological life forms, replacement of people in different jobs, and cheating. What have the neural networks been learning lately? All of the new skills and superpowers of artificial intelligence-based systems in today's one episode. Alphabet, the parent company of Google, recently unveiled Isomorphic Labs, a lab tasked with finding new drugs using DeepMind artificial intelligence. The mission of the organization will be to redefine the entire process of drug discovery from the ground up and find new ways to cure diseases. Using artificial intelligence, Isomorphic Labs will not only analyze data, but also build powerful predictive and generative models of complex biological phenomena. And while no one trying to find cures with neural networks has achieved any significant breakthroughs so far, DeepMind is currently the leader in AI, and its algorithm learning system are the most adaptable to repurpose for different tasks. Neural networks are also actively used to train robots. For example, a new model based on artificial intelligence has helped MIT engineers train robots to hold more than 2,000 kinds of different objects in their manipulators. Using an algorithm with reinforcement without simulation, they create a simulation of an anthropomorphic hand that could manipulate more than 2,000 different objects. And what's more, the system didn't need to know exactly what it was going to pick up in order to hold the object in its hand. So far, the success rate of the robot using the system varies depending on the object. It's much easier for a robot to pick up a box or a ball than a pair of scissors or a screwdriver. But over time, the algorithm will improve itself, making robots more dexterous and versatile. Another algorithm by MIT researchers teaches robots social skills, particularly mutual aid. The new mathematical model is designed to give machines an understanding of the physical and social actions of other robots. So, if a robot is about to perform a socially meaningful action, another robot should help it if the action is good, or hinder it if the action is bad. Researchers plan to equip robots with a neural network to speed up the process of social experience. In addition, they are working on a 3D sensor system that will allow robots to perform more complex operations on their own, such as operating household appliances. All of this will allow robots to increase interaction not only among themselves, but also between humans and robots. Another surprising discovery was made at the University of Brain Research at the same Massachusetts Institute of Technology. There, scientists found that when classifying odors, artificial neural networks adopt a structure that closely resembles the structure of the brain's olfactory circuitry. Humans and animals process odor information the same way in the brain, but in training the algorithms to classify odors, scientists did not aim to replicate the brain. However, in the process of solving the problem, the artificial neural network accurately reproduced the biological network. On one hand, this speaks of the optimal design of biological systems, and on the other hand, it allows us to propose the possibility of general modeling of the brain. And one of the most important functions of the brain, recently also mastered by artificial intelligence, is the identification of cause-effect relationships. Researchers from MIT proved that a certain type of neural network is able to learn the true causal structure of a task it's trained to perform. The research was conducted on navigation neural networks and designed to keep the unmanned car on the road or be responsible for drone navigation. The point is that when you train a neural network, you can't know for sure if it has learned to keep the road on the markings and on the horizon, or the bushes along the road. If the algorithm has chosen the wrong data for training, it won't be able to perform the task when the environment changes. The researchers use so-called fluid neural networks, which can change their basic equations to constantly adapt to new input data. A brain-inspired deep learning system built on such networks shows the same results as standard algorithms under the standard conditions, such as good weather. But unlike conventional neural networks, it also does a good job of navigating in fog, heavy rain, or other climate changes. The algorithm understands how change affects its results, and it adapts to them to optimize the result of the new conditions. Neural networks are also used for simpler tasks. Thus, the American edition Miami Herald replaced a fired journalist with a robot. The Miami Herald bot algorithm writes about real estate, and during 2.5 weeks of work, it produced 50 articles marked by a bar that said the text was generated by AI. A neural network collects data on the location, the bidding date, price, and area of the property into a single text. So far, the bot does not work perfectly and does make factual errors. Nevertheless, the generated articles do read, and so far, the editorial office is not going to hire a new journalist. It's currently known that the service of bot writers are used even by such publications as Forbes, the Associated Press, Bloomberg, Guardian, and others. Nvidia recently introduced a neural network that creates animated 3D models of faces based on the voice. The program Audio to Face generates not just a face, but all the accompanying emotions and articulation of speech. The program runs on platform Nvidia Omniverse and creates models in real time. You only need to download the audio track, and you can even in Russian. If you want to know how the neural network represents your appearance, follow the link in the description of the video. Within the framework of AI Journey 2021 conference, Sber has presented the code generation model based on the ruGPT-3 neural network. The ruGPT-3 model is the basis of the system jokingly named Jarvis, just another really valuable intellectual system. Created by the Sber Devices and Sber Works team. One of its parts is a service that allows you to automatically write code, reducing the development time. External developers will be able to use this function from November 15th, as the service will be available as part of the Smart Market, a single point of access to all Sber's technological platforms. The model's capabilities include adding developer code, searching for vulnerabilities in it, and translating from one programming language to another. And in the future, Sber plans to train the neural network to transform an algorithm formulated in ordinary speech into code. On November 2nd, Sber Devices, Sber AI, and Sber Cloud teams announced multimodal neural network ruDALL-E, which creates pictures based on a given description in Russian, and immediately launched a demo site where you can try it out. We'll also leave a link to this down in the description. For example, here's how the neural network sees the coolest robot, artificial intelligence, and the future of humanity. Also, at the AI Journey conference, Sber unveiled a second neural network training supercomputer, Cristofari Neo. It was created by the bank subsidiary Sber Cloud and based on Nvidia technology. Cristofari Neo has a performance of 11.95 petaflops. The A100 tensor cores provide performance in artificial intelligence learning tasks. There's also 80 gigabytes of memory, which allows you to work with large AI models and datasets. And by the way, Tesla is creating its own supercomputer, expecting to make a breakthrough in autopilot training with its help. But we'll tell you about that in an upcoming episode. Subscribe to the channel, like this video, and don't miss any new episodes from the world of high tech.